Okay, cool. Here we go. So we're talking about adding inequalities, subtracting inequalities to solve. So we've solved equations before, right? But we want to subtract. We want to solve inequalities by adding subtract. So I want you guys to solve the equation. Go ahead and solve the equation on the left. All right, let's just solve it. Of course, the first thing we want to do is what? We're going to build our wall. Circle the variable. Then what? Use inverse operations. So what's the inverse operation here? From starts with a B. From starts with a B. A variable. Your answer's unbearable. From both sides, y'all. Everybody say both sides. Good, from both sides. And we're left with, turn it off. C equals what? 4. Now, obviously, that one was a pretty easy answer. Okay? So let's solve the inequality. What do you think we should do? What do you think we should do? What do you think we should do next? What do you think we should do next? I already did that. Keep your eyes up.
I think you're supposed to minus 4 on both sides then.
Do what?
Minus 4 on both sides.
Yeah, subtract 4 from both sides, and what do we get? We get
4. Is it the same thing?
we don't get the same thing. We get C is.
C, like greater than.
So use the right words. What is that symbol?
C is
Greater than 4. So when solving inequalities, okay, we have an infinite number of solutions possible, right? Give me some answers that are greater than 4. 7.
10.
10. Great. All those numbers are great numbers. There's an infinite number of solutions, right? This is why we have to graph the solutions to show all possible answers. Okay? So we've got to graph those solutions to show all the possible answers. So when we're looking at this, keep in mind, there's one solution, right? What's the solution? C equals 4. Here, there's an infinite number of solutions. Right? 7, 10, 8, all those. 100. So that's why we need to graph it. So let's graph it. We, of course, need 4, and we need at least one number less than that. What's a number less than that? 3 and 2, and then 5, 6, right? And now, open or close dot.
Open.
Facing which direction?
Right.
Why is it going to the right? Because the variable's on the left, and it's greater than. The symbol greater than points to the right. Okay? Once again, this is what we've got. Did you notice anything about the differences between those two? The only difference. What's the biggest difference? Equal sign and equality sign. So what mistakes do you think you guys will make?
Put an equal sign.
To put an equal sign. So put a big note to yourself. Don't put an equal sign. All right? So let's kind of summarize. When we solve inequalities with the exact same goal and steps as we do an equation, we just have to be sure to keep the inequality symbol and not put an equal sign. Right? And not put an equal sign. So what's our goal? What's our goal, y'all? Say it all together.
Isolate variable.
How are we going to do that?
Use inverse operations.
Exactly, good. And the steps are going to be the exact same. What's the first thing we do with our steps? Build a wall. Okay? Then what? Circle the variable. And the coefficient if it's a two-step, right? If it's a two-stepper, we would circle the variable and the coefficient, but right now we're going to stick with one-steppers for now, just for today. And then we do the inverse operation on both sides. Okay? So let's solve and graph this inequality. Okay? what's the first thing we need to do? Build that wall. Okay. Then next thing, circle that variable. What operation is currently happening? What operation is currently happening? Yeah, x minus 9. What's the inverse of that? X
Plus 9.
So we need to add 9 to both sides. Of course, please don't forget to do this. Alright? Please cross them off. It helps you see what's left. What's left on the left side? What's left on the left side? What's left on the left side? Good. Show me your left hand. Everybody raise your left hand. Good. Just want to double check that we know our rights and lefts.
I did one. Well, there's
All right, put your hands down. So what's left on the left side? What's left on the right side?
5 plus 9.
Which is
14.
14. And what symbol do we have?
Less than.
What is that symbol? It's less than or equal to. So we need to graph this, right? So we need 14, and then a number on either side of it, less than or greater than. So we have to identify from our notes from yesterday. Is this going to be an open or a closed dot? It's going to be a closed dot. Which direction is it going to point? Which direction? It's going to point left. Why? Because the direction of this arrow is pointing left, and the variable is first. And less than left. Questions? We've done this before, haven't we? So today is kind of combining solving one-step equations and what we did yesterday. It's kind of what that is. So let's do one with fractions. This is an easy fraction one. Chill out. Why is this an easy fraction one? We got the same denominator. Nice. Awesome. So build our wall. Circle our variable. We're adding 2/5 to both sides, so we need to subtract 2/5 from both sides. 3/5 minus 2/5 is an easy fraction one. 3/5 minus 2/5 is what? 1/5. And what's the symbol that goes in the middle? Less than or equal to. Good. So is this an open or a closed? It's closed. Which direction is it going? It's going to go left. And so we need to have 1/5. Now what should be on the right? 1/5, then 2/5. Now what's less than 1/5? 0. So you need to have at least one that's greater than and one that's less than it. And it's a closed dot, right? So it's closed, pointing to the left. Julio?
Yeah.
All right. Let's do it with decimals. You guys want to do this one on your own? Yeah, do it on your own. Go. Try it out. I'll show the answer in a second. You're in your pink things. We had it yesterday. Go get those. And this time keep track of it. You have a binder here with 3 rings that needs to be attached because there's 3 holes in there. You might need to do some side work on this one. You need to do side work. Do it. Keep in mind, you need to wrap on this one, don't you? Yep. Look up once you're done.
Yes, I got to see it.
Probably want to have some side work for this one if you can't do the subtraction in your head. Why is it subtraction? Kobe?
Because you said why are you subtraction?
Yeah, why are we subtracting?
Because yeah, same thing. Add different sides subtract.
Good.
I got confused.
So on the right hand side, why are we subtracting? Because well, but it looks like I should be adding, right? Shouldn't I be adding 4.9? No. We add wrap, don't we? We add wrap. So what are we going to do? We have the same sign, add different signs, subtract. Then we'll keep the sign of the bigger one, so we can be exact.
What? Those are that shy.
Exactly. Oh, sweet. I don't play basketball. I'm 5'6". That's just how it goes. And why is it closed? Because this is a less than or equal to. Okay? I didn't realize that every symbol that we have on our notes, with the exception of the very first one, is or equal to. I'll have to change that for next year. I'll have to make sure that it's not. Okay? Here we go. This one looks a little different. Why?
Because the variable is.
The variable comes second. How's that going to change what we do? We're not going to have to switch anything because the variable is still on the left-hand side of the sign. But most of the time, guys, you guys see things that look like this. Most of the time you see that. The variable would come first and then the operation is happening to it. But here, the variable is coming second. It still shouldn't matter. Because when we build our wall and circle our variable, right, we circle our variable and it's what? Coefficient. So what's the coefficient of t? Positive 1. Did you see that I included the plus sign in there? It's important to include that plus sign. So now what's happening to this positive t? There's this minus 17, right? Subtraction 17. So we do the inverse of that. Plus 17, plus 17. Okay? The inverse. It says negative 17 plus t. That's an addition problem, right? It's a subtraction problem. So that'll cancel. And then on the right-hand side, I need to add wrap, right? So I'm left with t is greater than or equal to 5. And it's closed. Keep in mind, none of these had the variable on the right-hand side. If the variable is on the right-hand side, what do we need to do? We need to flip it over to the left. Keep that in mind as you're working through this stuff. All right? So, let's do some word problems here. The steps that we need to do, first thing we need to do is we need to write the inequality, then we need to solve that inequality, and then graph the solution. Okay? We need to write that inequality, solve the inequality, and graph that solution. Those are the 3 steps to word problems with inequalities. Write it, solve it, graph it. Everybody say, write it, solve it, graph it.
Right.
It's like a cheer. Who's in cheer in this class?
Maddie.
Yeah. Let's make up a cheer for write it, solve it, graph it. What do you think? I don't know. Write it, solve it, graph it.
What even is that name?
That's the write it. I can't. Write it, solve it, graph it. I don't cheer. My wife's a cheer coach. I'm not a cheer coach. Anyway, all right. So here we go. To get an A, you need more than 200 points on a 2-part test. You score 109 points on the first part. How many points do you need? Now, I understand that you guys know how to do this, right? Without writing an inequality. However, you need to write an inequality. Keywords. More than. Okay? So, what's our variable going to be?
P.
Sure, why not? P is going to stand for the amount of points. Number of points, amount of points needed. Right, the amount of points needed like on the second part, right? Let's write our inequality. So how many points do we already have?
109.
Good, so we start off with 109. Now on the second part, what do I need to add to that, right? How many points am I going to add to that? I'm going to add the number of points that I need in the second part. So this is the first part plus the second part should be what? I need what? More than 200 points. So more than 200 is written as what symbol? Greater than symbol. There we go. That is our inequality. Now remember, you guys said, well, we need to do subtraction, right? In your head, you're thinking, I need to subtract. Why? Because when I build my wall, circle my variable, and its coefficient, what do I need to do to that 109? And move it over to the other side by subtracting it. So that helps you know that you set up your inequality correctly. Because in your head, you're thinking, I need to subtract here. And so now, am I subtracting? Absolutely. I'm doing what I needed to do. So P is not equal to 91. It's greater than 91. So is that open or closed?
Open.
Open. In which direction am I pointing it?
Right.
It's pointing to the right. So 91, 90, and 92. Open. Pointing to the right. That is what it takes to word problems in inequalities. Okay? Let's do the second one. The theater can hold at most 205 or 225 people. The theater has already admitted 132 people. How many more people can the theater admit?
Do subtraction.
Well, I think we want to do subtraction, so we'll probably set up our inequality. Our inequality will probably have addition in it, though. Then if we're wanting to do subtraction, it'll probably have addition in it. Because subtraction would probably be our inverse operation, right? So you need to write the inequality in words. What's the key word for this one? At most. Good. So what do we want? What do we want our variable to be?
P.
P.
I said
You said T?
I said P.
I'm going to use T this time.
Yeah. Peppa Pig.
T for what? Notice when you define a variable, you have to say T equals, or what is T? T is going to be what?
How many people can admit to the theater?
Number of people that can come. Right? Or that the theater can admit. So, how many do we start with? 132. What do we need to do? Plus T. Why are we adding T? Because we already have 132 people in it. We then need to add the number of more people that can get in there. And what do we have to do? At most. You might want to flip back into your notes if you are unsure about the words at most. That one's going to be
It's less
less than or equal to 225. Now, Kobe said earlier we need to subtract, right? He's right. We do need to subtract. So why do we need to subtract? It's because when we set up our problem, when we do our inverse operations, what inverse operation are we going to do? We subtract 132. And we get T is less than or equal to 93. 93. So, 93, 94, 92. Open or closed?
Close not.
Closed. Which direction, left or right?
Left.
Left. Okay. Questions? Ladies and gentlemen, writing inequalities is tough because a lot of times you read the situation and you think you know what to do. You know what you do? So like, instantly you're like, here, oh, I need to subtract 132 from 225. And you're right, you absolutely are right. But we're writing an equation to represent the situation, not to solve. The equation represents the situation. It doesn't do the solving. You have to use inverse operations to solve. So if your instinct is to subtract, your equation is probably going to have addition in it. Because if your instinct is to subtract, that would be the inverse operation. Right? Was your instinct to subtract? When we set it up, how did we have to set it up? We had to set it up as addition because we're adding more people. It says there's already this many people. How many more people can come in? That's adding. Okay? That's adding. So a lot of times if you think if your instinct is to add, then you're probably going to have some subtraction.